All right, welcome back. This is 4.5, day 2 notes. So find your packet, and you're going to turn to example 3. So we're going to finish up 4.5. Example 3 says, what are the solutions of the quadratic equation x squared plus 2x minus 10? Okay, so you look at the equation. And do you see they're not on an integer? So we are going to estimate these. If you happen to have a graphing calculator, your graphing calculator will actually do this for us. Okay, so for those of you with a graphing calculator, you open a new document and it'll say add a graph. And you'll do x squared plus 2x minus 10. And then you'll press menu. Number 6 is analyze. And then you're going to find the zeros. If you see that function. And so this one is at 2.3. And again, I'm getting this off of a graphing calculator, so if you don't have one, you might feel a little confused. But if you have one, this is at negative 4.3, okay? And I used a graphing calculator to get that. So you can, so here's kind of the cool thing is, okay? The x-intercepts are the solutions, okay? The x-intercepts are the solutions. So let's look at example 4. It says graph the function f of x equals x squared plus 2x minus 8. So we actually did this before. So this is a nice review, but we're going to add one piece to it, okay? We're going to add one piece. This one opens up. If it opens up, it has a minimum. To find the vertex, do you remember that was negative b over 2a? So that's negative 2 over 2 times 1. Negative 2 over 2 is negative 1. I'm going to go find the y value. So that's negative 1 squared plus 2 times negative 1 minus 8. So that's 1 minus 2 is negative 1 minus 8 is negative 9. So my vertex is negative 1, negative 9. So you guys, this is review, complete review from 4.1 and 4.2. If you're feeling overwhelmed or lost, you need to pause this. You should go back and look at your 4.1 and 4.2 notes. The axis of symmetry is x equals negative 1. To find a y-intercept, you let x equal 0 in the equation up here. If x is 0, then the y value is negative 8. So let's plot these. I go to negative 1, negative 8, 1, 2, 3, 4, 5, 6, 7, 8, 9. So here's negative 1, negative 9. I have a y-intercept at 0, negative 8, so my symmetrical point will be negative 2, negative 8. Then it says, so here's something interesting, where I have f of x equals x squared plus 2x minus 8. If I set it equal to 0 and factor it, do you see that that factors into x plus 4 times x minus 2. So I can set x plus 4 equal to 0 and x minus 2 equal to 0. So this is x equals 2 or x is negative 4. These are the x-intercepts. So I'm going to plot 2 and negative 4. So this is negative 4 comma 0 and 2 comma 0. Again, if you can take your quadratic function, set it equal to 0, and factor it, those will give you, not only are they the x-intercepts, but those are also your solutions. So the domain is negative infinity to infinity, and this is a range of negative 9 to infinity. And I want you to add a row down here if it's not already on yours. My zeros are the x-intercepts. The solutions are x is negative 4 and x is 2. So the x-intercepts are the solutions. So what's really neat, what's really neat about what we've done previously is we didn't know it at the time, but when we were graphing and we found the x-intercepts are the solution to the quadratic equation. All right, example 5. The function y equals negative 0.03x squared plus 1.60x models the path of a kicked soccer ball. Y is the height, and the distance is x, and the units are in meters. So what I want to do is, I've got my vertex is x equals negative b over 2a. So it's negative 1.60 over 2 times negative 0.03. So that's going to give me a negative over a negative, which is positive. And then I'll take 1.6 divided by 0.06, and I'm getting 26.67. That is the x-coordinate of the vertex. To get the y-coordinate, you're definitely going to want a calculator here. And then you're going to plug it in to get the y value. So I'm going to kind of hang on here while you work it out. I'm getting 21.33. So now this is the halfway point. If this is the halfway point, what do you think it is when it hits the ground? Well, it's going to be 26.67 times 2, which is 53.34. And then the y value is halfway, so you're going to multiply that by 2 and get 42.66. So the maximum height is up here. And this is, oops, sorry, that one isn't 42. Sorry, this is 0, right? Because it hits the ground, the height is 0. Sorry about that. So it takes a distance of 53.34 meters before the soccer ball hits the ground. This is on the ground. Sorry about that. So how far does the soccer ball travel? That was the 53.53. 53.34, and that was meters. How high does it go? That's this number here, 21.33 meters. And describe a reasonable domain and range. So here's the deal. Even though this is a parabola, it doesn't go negative infinity to infinity. You start at no distance, and then it hits it at 53.34. So my domain would be 0 to 53.34. My range are the y values. Okay, so the domain is how far left and right does it go on the x-axis. So let's go back. So it went from 0 to 53.34. On the y, it's 0 up to 21.33. Okay, so that finishes 4.5 notes, day 2. I don't want you to panic if you're feeling lost or confused. This is a very short video. Watch it a second time before you throw up the towel and say, I can't do this. Okay, watch it again.